Hi, I want to do a video about mixture problems that are kind of percent problems similar to what we've been doing in class. So let me start. So what we're going to think about for mixture problems are where you have X units of one quantity over here and Y units of another quantity, and you combine them to get some total X plus Y units. And they're at different rates. So maybe the first thing is at rate for X, and another is at a different rate, and then there's a mixture rate, so some combination. And how do you set up an equation in a situation like that, and how do you solve problems? So here are three typical problems. So one might be that you have 3 pounds of coffee it's $5 a pound for that coffee. And you want to mix it with better coffee, 7 pounds each of those are at a rate of $8 per pound. So you have a cheap rate and an expensive rate, and you mix them together, you combine them, and you end up with 10 pounds of coffee. But what's the mixture of that? What's the rate, the dollars per pound for the mixture? It's going to be between 5 pounds and 8 pounds, the cheap coffee and the expensive coffee, but where in the middle? How do you solve that? Another example might be, let's say you're in chemistry and you have 100 milliliters of something that has 3 grams of sodium per liter. It's how much sodium it has and how much salt it has in it. And you've got 100 milliliters of 3 grams per liter, and you've got 200 milliliters of something, and you don't know how much salt is in that mixture. And when you add them all together, you have 300 milliliters of something, and that ends up having 10 grams per liter as its salinity, as its amount of salt. How salty was the middle mixture? How do you solve that? So you're mixing two things that are at different rates, grams per liter. You had above, you had dollars per pound. That's another rate. Another rate we've talked about is a percent. A percent is just a rate per cent. It would be 500 people, and maybe 20% of them answered yes on a survey. So 500 people at 20%. And then you had another group of people, you don't know how many they are, and they answered 35% at a rate of 35% yes. So we don't know how many are in the total. It's going to be 500 plus the unknown in the middle, but we know the overall percentage was 30%. So there was one group at 20% and one group at 35%, and you look at the mixture of those, and you end up at 30%. So how do we figure out how many were in the second group, and then how many were overall in the total? We can answer those questions, and let's see if we can do those. They're all 3 different types of problems, all set up in exactly the same way if you consider the units as just a rate. So let's look at 3 pounds at $5 a pound is 3 pounds times $5 per pound, dollars per pound. And you've got it set up so that the pounds of the pounds cancel, and that's $15. Plus, then you've got here 7 pounds at $8 per pound. And just like we've been doing with units, that's going to be $56. And over here, we've got 10 pounds at X dollars per pound. So equals 10X dollars. And if you've done this correctly and you've got the units set up well, everything should line up very nicely. And you've got, what is that, $71 equals 10X, so X equals $7.10. So the mixture is going to be $7.10 per pound. What if you had a different problem, the chemistry problem? You set it up the same way. You've got every one of these is going to be these percents, and you've got the amounts, 100 milliliters and 200 milliliters. It ends up being 300 milliliters, and you multiply those by the rates. So 100 milliliters times 3 grams per liter, and 200 milliliters times X grams per liter equals 300 milligrams at 10 grams per liter. And once you've got your units all lined up very nicely, the math just becomes 300 plus 200 X equals 3,000. Did I do that right? Yeah, 3,000. So 200x equals 2,700. X equals 13.5. 27 over 2, 13.5. And what was that? That's grams per liter. Grams per liter. So the middle had to be stronger, more salinity, more salt content than the final mixture, because the final mixture is going to be an average, not an average, but in between the low value of 3 grams per liter and the high value of 13.5 grams per liter. So we'll mix those two and we'll get something in between somewhere. And in this case, it ends up at 10. So you can, if you do those 6 parentheses, those will set up most of these problems. So let's do one more. What about with a percent? So we've got parentheses, parentheses, plus parentheses, parentheses, equals parentheses, parentheses. How many people? 500. X. And how many are going to be in the total? It's going to be 500 plus X. Right? That logically makes sense. And what are the percents? And you can do 20% as 20 hundredths, or you can do it as a decimal. Doesn't matter how you want to write it, but at the end it's 30%. 20% of the first, 35% of the next, 30% of the last. So 20% of 500 is 100 plus 0.35x equals this. You have to distribute. 30% of 150 or 500 is 150 plus 0.30x. And now we just solve. And so let's subtract 0.30, whoops, 0.30x minus 0.30x is 100 plus 0.05x equals 150. 0.05x equals 50. Divide by 0.05, or a better way to do that is multiply by 20. Right, because 0.05 times 20 is 1. So maybe that's an easier way to think about it. And that is going to give you x equals 1,000. So we must have had 1,000 people at that higher percent, 35% rate. And so we're going to do these in class, setting them up and kind of visualizing them as a percent, as a mixture problem is great. Setting them up in these situations is how you can do this. And then you solve for whatever's missing, whatever value is missing. I'm going to show you some intuitive ways in class to think about how these are going to work in terms of if you mix a little bit of the low value and a lot of the high value, it's going to be closer to the high value as an average. If you mix them equally, it's going to be right in the middle. We'll talk about that in class. But here's an example that I had in the as a bonus question for the daily assignment for last Friday. Suppose you are filling a kiddie pool with water, and you have 2 hoses, and you have one hose that, from past experience, you know it takes 45 minutes to fill the pool. So that's a rate. How fast is the water flowing? And you can think about it as minutes per gallon, or what? But let's just say minutes per pool is the units, because we don't need to know how big the pool is. And we have a faster hose over on the right, and that goes at 20 minutes per pool. So that's flowing at a faster rate. So if I combine these, if I mix these and I have them both going together, how fast should I get, how long will it take to fill the pool? And it looks like minutes per pool equals minutes per pool. The units look like they work, but something's different about this one. And I want you to think about it, and I'll talk about it in class. But what's different about this? If one hose takes 20 minutes and I have another hose that takes 45 minutes, it shouldn't be 65 minutes to fill the pool, right? It should be faster. This can't make sense. I have one that's filling it at 20 minutes. If I have another, add more water, it should fill it faster than 20 minutes. Why? What's wrong about this? And why don't these units add the way other units do? Here's the key to think about that. You can't add minutes when two things are working together. It should decrease the number of minutes, shouldn't add the number of minutes. So in this case, if you flip it over and think about it as it fills 1/20th of the pool every minute. And the second hose fills 1/45th of the pool every minute, per minute. And the last one is going to fill I don't know, whatever X minutes is, it's going to fill one X of the pool in 1 minute, per minute. And those do add, in the sense that, pretend you let the big hose fill for 1 minute, it fills a certain amount of the pool. Then you let the other one fill for 1 minute, that'll fill another amount of the pool, and those will add together. So if they were filling at the same minute, that would be the combined total. So these can add in that way. And so you have to think about logically in the context of the problem, do they add correctly? And so you get 1/20th plus 1/45 equals 1/x. And you can solve for that by getting a common denominator